Next thing I'll just touch on is some things that don't quite go right when we're using that. So some gotchas when using SpriteKit with ARKit in this way. Shape nodes don't work. Shape nodes will give you an instant crash. Enumerate child nodes will also give you intermittent crashing. Threading is a bit different. So in SpriteKit world, both your user input and your SpriteKit update loop both operate on the main thread. When you're running in ARKit, your gestures are still on the main thread, but the SpriteKit update loop is being controlled by ARKit, which is running on its own thread. If you're using user input gestures to modify the hierarchy of the SpriteKit node tree, specifically when using physics bodies, I've found that a problem. You'll get a condition where you're manipulating the node tree in one thread while SpriteKit's trying to do its processing of that node tree in another one, and you run into array enumeration exceptions. So the technique we had to use there to fix that was to say, when I get a user gesture, just queue that gesture over to the ARKit thread so that it can be properly processed on the ARKit thread, and there'll be no problems. So that's all. Thank you very much for listening. My name was Simon. I'm the practice manager for mobile web custom dev at Oakton. If anyone's doing anything cool with ARKit, I'd love to catch up for a chat afterwards. So thank you for your time.
Thank you, Simon. That was excellent.
No worries.
I'll take your questions, Simon.
Okay. Hello. If you don't know me, my name is Vlas. I work at Itty Bitty Apps. And today I'd like to show you a little behind the scenes for this little AR demo we made related to Reveal. Now, you may have seen this tweet from Reveal that actually shows this demo. But regardless of, you made some rounds on Twitter.
That's nearly better than Barry's one.
No, it's not even close.
Well, but regardless of whether you've seen it or not, I am going to show it to you now. So, in order to do that, we will just launch this thing. Okay, so obviously because it's an AR demo, we'll need a surface. We will use this floor plan as a surface because it's good enough. It has enough feature points. So what I will do now is I will put an app that has been specially built for this purpose. Well, not specially prepared for this purpose. In here, I will do a magic gesture, and it shows up. Please excuse the precision because a Apple-designed wooden table would obviously be much better for this particular demo. But still, we can look around. It obviously glitches a bit. Look around, see inside the view hierarchy, even toggle wireframes on and off. And change the expansion level. And we can even switch to Soundstagram, which is what I'm doing right now. Whoop, whoop, and we got Soundstagram in. Well, that's cool and all, but obviously the question is, okay, well, how does this work? Well, spoiler alert, it's all fake, but okay, it's not all fake. Let's say half of it is fake. So, we got some problems to solve here to make this demo work, right? We first need to load the view hierarchy into our SceneKit scene that's integrated with the ARKit. We do need to correct the scale of the view hierarchy that we have loaded, and we do need to implement position and orientation tracking for the phone that we point the camera at. So first, loading the view hierarchy. That's the easiest part. Because why? Well, we have Reveal for that. Reveal already allows us to load the view hierarchy from the iOS app and create a scene, a 3D scene out of it, which is great because, well, we'll just get to extract the SceneKit scene that Reveal produces into an SCN archive. We get this, which is, it's a bit washed out, but it's a screenshot of SceneKit editor, which did crash a little bit on Xcode 9, of the scene that has been exported from Reveal. And so we just load it in our AR app, place it into the SCN view, and we're done, right? Well, not really. The problem, obviously, is it's too huge. Why? Well, ARKit, as you've already heard, works in meters, in physical units, but Reveal scene is in UIKit points because, well, that just made sense. And so if we load a view hierarchy that is 375 points in width, that means it'll be 375 meters wide in the AR world, which is not good. We want to scale the view hierarchy down to the screen size. Well, yeah, the question is, okay, well, how do we know what's the scale? Well, luckily, we do know something about iOS devices, and that is they have a pretty predefined DPI. On most iPhones that are not Plus or iPhone 10, it's 326. On most iPads, except for iPad mini, it's 264. So we can, just make it work by just taking a look at what's the device type, maybe what's the scale for 8 Plus or iPhone 10. The things get complicated. The demo was done before iPhone 10 came out, so yeah. So we can just derive the DPI from device type and scale, and iPad mini be damned. Or alternatively, if we would actually collect this information and reveal, we could take the device identifier, like iPhone 10, 3, which is iPhone 10, by the way, and just have a table that gives us the TPI. Theoretically, there's like a private API or something that allows you to take that information out of UI device, but I did not go that far. Anyway, we do have DPI, and the math is pretty simple. You just multiply your SyncKit points, you multiply the view hierarchy points by the screen scale, multiply that by the constant for inches because imperial units, and divide that by DPI. And you get, this doesn't really look good, but it's a really dark screenshot of my table, and obviously it was 10 p.m., so it was dark. But the idea is it actually nicely scaled the view hierarchy snapshot down to a screen scale. Nice. Okay. Well, the hardest part still is the position and orientation tracking. We do want to detect where the screen is, what's the 3D location of its center in the real world, well, the AR simulated world, and we do want to know its orientation so that when the screen is being rotated, which is something I did not show, by the way, the snapshot gets rotated as well. Yeah, that's the hardest part. But first, before we get into that, a little bit of background about ARKit. So, what does ARKit provide to us? Actually, quite a lot for the first release. We get a live video capture with access to per frame information, like basically the video buffer and the ARKit derived data for that particular frame, like anchors and camera intrinsics and stuff like that. We do get feature detection and tracking on the captured video frames. Features are basically edges. ARKit runs a edge detection algorithm on the frames to find out those little points of texture in the real world it can grab onto and track. It also gives you device orientation tracking, which is 3 degrees of freedom through accelerometer and gyro information. And if you have a newer device, it also gives you position tracking, or so-called world tracking, using visual odometry. That's basically, that uses the feature detection to track how much these particular features have moved around. It merges the data from all these different sensors, accelerometer, gyro, cameras, and detects how much you have actually moved the device around. On the iPhone 10 True Depth camera, it also allows you to do face and depth tracking. It does allow you to do horizontal plane detection, tracking, and merging. So, for example, if you have 2 blobs of texture on your floor, it detects one blob, then another blob, then you move around a bit, it detects, oh, actually, these are the same planes. It will actually merge them together, which is good. It uses a coplanar feature point estimation algorithms, again, using those feature points that detected from the video buffer. It does allow you to hit test with those detected planes and feature points if you're not looking for actual horizontal planes. And it detects ambient lighting for rear camera and direction lighting for front camera on iPhone 10. And there's built integration with SyncKit and SpriteKit, which is really convenient. But what's also important and interesting is actually what it does not provide just yet. Really importantly, it does not allow to identify or track objects like markers. Many older AR libraries actually are based on that. So for example, I think OpenCV has an implementation that uses AR markers and detects them using image detection and tracks those. So instead of using visual odometry, because I guess they cannot really rely on camera intrinsics being really precise, like what Apple can do, only Apple. They actually use marker detection, which is also great, which is also an important part of AR. But ARKit doesn't do that just yet. It doesn't allow you to detect vertical planes, unfortunately, and It also doesn't really work well when the environment around the device really changes. So for example, if you have a horizontal plane, but then maybe it was, I don't know, maybe in a minute that horizontal plane went away. Well, ARKit will not know about that. It will still think that horizontal plane is there, which again for release number 1 still is all pretty good. And also doesn't allow you to record and replay the sensor data, which would be very convenient for debugging. I also say yet here, because if you actually use Hopper and look into ARKit binary for simulator, which exists for reasons, I guess. It's like, why would you use ARKit on simulator? But still, it's there. If you actually look into that, at least points 1, 2, and 4 are in one way or another are referenced in there. So I would expect a lot more things, at least in iOS 12. So, okay, we cannot do these things yet, so what do? Well, we need to detect the device screen, its center and orientation. We need to track it as it moves and rotates. So ARKit doesn't really provide that to us, so what do? Well, it's time for some synergy. So,
Are you working at the bank at the moment?
I am not in the position to tell you that right now. So, we do have access to captured video frames. That means that we can actually go crazy. We can integrate other libraries like, again, OpenCV, which is like 100 megs large or something, and do other sorts of image analysis on those frames if we like. Like we can actually detect markers if you wanted to. But also introduced in iOS 11 was the vision framework, which means that we can do quite a lot of different kinds of image or video analysis on those frames. Like, I don't know, detect rectangles, maybe like show a pink screen on the phone and detect that particular pink screen, or maybe even try to detect the image of the screen that we've captured using Reveal in the captured video or something, maybe even run a custom neural network that detects iOS apps or something, I don't know. Well, the easiest option for that particular demo was, well, we can just detect barcode, specifically QR code. And the good part is that the results, the barcode observation, provides you both the encoded data, which we could use for different purposes, and oriented corner locations. So you can know specifically where on the image are the top left, top right, bottom left, bottom right corners of the QR code. So even if the QR code is rotated, you will get that information, which is awesome because we can detect them, we can actually put them in the 3D space and derive orientation position from them. A little bit of, and that's just the debugging feature, so it just shows where it has detected the QR codes in and where's the center. A little bit of graphing, scheming. So we have ARKit. ARKit provides us with a video buffer and detected planes in each AR frame. Now, using the video buffer, we can run a vision framework barcodes request, asynchronously, obviously. That gives us barcode data for app ID. That's how the demo app could switch between Revert and Soundstagram, because the QR code actually encodes the little identifier of the app that is being displayed. And it gives us the locations of corners of the barcode in the image in the buffer coordinate system. But using that coordinate system, using those corners in image coordinate system, we can put that and detected planes through hit testing and some vector map. So we can perform hit testing through those image coordinates into the AR world, find horizontal planes, assume that the device will be on one of those horizontal planes, because magic, right? Thus detecting 4 corners of the QR code in 3D world. And then using some simple math, we can detect both the center of the QR code and its orientation. Specifically, we only need one angle, I think it's yaw, because, well, it's a horizontal plane. Again, we assume that the phone actually lies on a table or other horizontal surface, so it will only rotate on the vertical axis, so we only need yaw. We get center orientation. Another little important phase here is center and orientation ideally should be put through a rolling average filter just to smoothen out some of the noise that QR code detection will give you. And using that the results of that rolling average, you can apply those parameters on the scene node that has the snapshot and profit. A little bit of explanation on that math. It's pretty simple, but still. So we have this QR code in space. We have 4 detected corners. They will have 3D position, obviously. We create direction vectors out of them. We average out the location. We get the center of the QR code. And we average out those 2 vectors and normalize them. We get orientation. And using a simple arc10 formula, we'll get a yaw angle out of them. With the rolling average for the orientation angle, like a little trick is that you want to make sure, because the angle that arc10 will give you will be, I think, between minus half pi and plus half pi. And so if you have a rolling average, you probably want to stay inside the same pi range. Otherwise, you'll get some weird rotation when you rotate the device far away. But yeah, you can ask me later if you want to know more. And yeah, that was about it. There were some other tricks. The expand animation on the snapshot is simply just z-axis scale, because everything in a reveal snapshot is just planes, basically. We can just z-scale things. Wireframes can be toggled on-off just because reveal represents them in the scene differently, so I can just identify one kinds of scene nodes and another kinds of scene nodes. If you haven't noticed, there's actually a large black plane under the snapshot. It's just a little trick to mask out the device screen in case the positioning is not precise enough. Just to, it's a smoke and mirrors. Finally, some little bits of advice if you're interested in trying some AR yourself. Obviously, look through the Apple's sample code. It's pretty huge. There's like a huge utilities.swift file with tons of different functions. It makes you think like, why is it not inside the frameworks? Like, why do we need to have all that code in like utilities files? Like, whatever. Of course, test in a well-lit environment, because otherwise the camera will not give you enough feature points because everything will be noisy. You will need a surface with enough texture. Otherwise, once again, there will be not enough feature points for ARKit to detect planes, or even just stuff to grab onto, anchors. And I would recommend using wireless debugging, actually, because if your Wi-Fi configuration is good enough, it does take like a few seconds to copy the Swift dilibs, if you use Swift, over to the device. But once you do that, I think it does realize that they're already there on the device, so it doesn't try to copy them again. It works pretty well. If it doesn't work for you, try disabling Wi-Fi on both the device and the machine. I think it helps. And I would recommend building some debugging features into your app, like, for example, to render feature points. I think this one is actually integrated into AR SCN view. You can just enable that. Planes, like when you detect horizontal planes, it probably would make sense to put those planes inside your scene, just so you can see that ARKit actually detected those planes. And maybe some app-specific anchors. Like, for example, on the QR code, there was some cubes for the corners, so I can actually see that they are being detected and oriented correctly. And I think that's it. Yep, that's it. And questions?
We've got time for questions.
I've got one.
Mm.
Before Matt gets in. So which version of Reveal am I going to see this in?
Please ask Sean about that. Whoa. Rumors confirmed.
Money on the table?
Well, on a table with good enough surface.
I'm sure money provides a good enough texture.
All right. Anyone? Yep.
So there was a lot of scary maps in there.
No.
How
I
do
wasn't
you
scared.
actually get your head around all of that maths, and is it actually easier than it looks?
Well, it is quite easy if you have worked with 3D geometry before.
But
Well,
if you haven't,
if you haven't, I'm pretty sure there are some good resources online for that.
Really good books.
There are books, yep.
There are some really good books on
Yep. Like, oh yeah, just, hit me up, Yeah, but that particular geometry, the math wasn't really that difficult. It's just a few vectors. But obviously it did take some time to figure out actually what to do with all that data. Like, how do you integrate all parts together? How exactly do you extract what you want out of what you have? But that's, that's what software developers do, right? Well, yep.
You might just want to speak a little bit about how it's actually not transferring the view hierarchy at any point in time. It's actually baked into the iPad app.
Oh yeah, I mean, I was just hoping it's obvious. Yeah, the actual app, the IR demo app, just has 2 or 3 baked in synced archives in it. It just did. Wah wah. It just did.
The QR code to know which one.
Sean's the guy that the magician's there showing the cards through.
Smoke and mirrors. It was fun, right?
How long does it take you to do that?
Do you really want to know?
I think the audience might want to know how.
Sure.
How effort is involved.
It was.
15 minutes.
It was a few months ago. I think it was like maybe 5 evenings in one day or something like that. I don't really remember. Obviously, it took some time to actually figure out, okay, ARKit, all this API, what can we do with it? Not much, but not that little time either. So,
You could put
kind of
your
average.
ARKit renderer thing into an iPhone app, and then just move your data structure across the wire.
Well, that's what I thought I could do, right? But then I realized that it's just a demo, so maybe, for the demo purposes, fake a few things, right?
Good demo.
Good work, class.
Thank you. Oh, another question. Oh, okay. All right. Thank you.
That wasn't a question?